Welcome to the viewers. Now we discuss directed graph, or briefly say it is a digraph. Directed graph or digraph. But now in the earlier situations we only consider the graphs which have no direction. That is an undirected graph. But now here we study the directed graph. At first, if we consider by the definition, so directed graph, if we consider, let G be a graph we called G as directed graph or digraph, where we consider G a triplet. If we consider here V dash, vertices, G dash, E dash and omega dash incidence functions, then number 1 V dash, that is V1 dash, V2 dash is a non-empty finite set of vertices. Next is edges. So E dash will be E1 dash, E2 dash in this way is a finite set. It may be empty of directed edges. Or arcs. Now we consider here the third condition, very interesting results, that's the incidence functions. If we consider incidence function as omega dash, such that from E dash to, it is a mapping, omega dash is a mapping from E dash to V dash cos V dash, and it's clear already. That's a mapping omega dash from here, it is a set of E dash, and if we consider here as a set V dash cos V dash, it's a mapping, we consider here omega dash incident functions, and it is a function of functions which assigns to each arc E dash an ordered pair Vi dash Vj dash of vertices. So here we use the term arc for the directed edges, and if we observe Vi dash and Vj dash may be the same if possible, and one end point of the arc is designated as tail. If we consider an example, and if we observe here, at first let us consider a type of digraph, then we understand what happens. Already we discussed the primary three conditions, that's a very crucial for defining what digraph is. Now here we consider a figure at first. Suppose V1 dash, and here it is v2 dash, and if we consider a digraph here, and if we consider here a parallel edge, and if edges will be considered as e1 dash and e2 dash, then and from this graph there is a direction we put the arrow edges e directed from, that means v1 dash to v2 dash is e1 dash, and if we consider here that's a v1 dash to v2 dash another edges, that is v1 dash to v2 dash also same as another vertex, that means both have the same as a parallel edges, maybe a parallel edges if the incident function is omega dash, and this incidence only v1 dash to v2 dash, so omega dash operated with edges, that's the e1 dash, so it will be v1 dash v2 dash in this way, and as well as omega dash of e2 dash, it is also v1 dash and v2 dash. So in this way you can find, notation is first bracket table maybe, so in this way we find this type of diagram. And one point is to be noted here, if the starting point or that's a tail, or if another that is a terminal vertex is called the head, here it is the starting point of the vertex, that is the tail, and another is terminal point, that is a v1 dash to v2 dash, here also v1 dash to v2 dash, so it we call the starting point as a tail and the starting vertex, and another is terminal vertex or head, and the direction is from tail to head, so its direction is from tail to head. Here it is tail is v1 dash in the earlier figure, and head is v2 dash, so here is starting point, v1 dash is the starting point, so edge is directed from v1 dash to v2 dash, it is a starting point, it is a terminal point, so here is the terminal point. Now if we consider another thing, that's called a loop, what will be its definition in case of digraph? If we consider a digraph is said to be loop, its tail and head are the same, so if the tail and head of vertex are same, vertices are same, then we called it as loop. But from the given figure, if we consider one digraph here, if it is v1 dash, it is v2 dash, if there is a tail from v1 dash to v2 dash, if we consider a e dash, and here also another parallel edges like e2 dash, and here we also taking a vertex like a v3 dash, and from a graph here v1 dash to vt dash, that is v1 dash is tail to v2 dash, that is a terminal point. And here if we consider another loop, if we consider here that loop, that's the same head and tail, that is a, if it had e3 dash, it is e4 dash, So in this way we find. So incident function is omega dash. Omega dash of u1 dash, that will be v1 dash v2 dash, and omega dash, and that's of here omega dash of e2 dash. This is also v1 dash and v2 dash, so these have the parallel edges. Omega dash of e3 dash, that will be v1 dash and v3 dash, and omega dash of, very important in cases of loop, e4 dash, that will be v3 dash and v3 dash. So here we consider both tail and head in cases of digraph are same, so we consider this as a loop, and here it is parallel edges and tail and head is same, so it is called loop. And now we consider an interesting things called in degree and out degree of the vertices. And what is in degree and what will be the out degree? Here let G be the digraph, and if we consider V dash be a vertex of G, and in degree of V is denoted by degree V, that is in degree, so it will be V minus of, if we consider here V dash, V minus of V dash. So what happens actually there in degree? That means the number of the arcs with V as head, then we call it as in degree. If V dash is called head, then it is called in degree, and out degree is called V plus, that will be the number of the arc V as tail, then it is called out degree. That is the number of arcs with V dash as head and out degree of V dash is given by or defined by D plus V dash, and that is the number of arcs with V dash as tail. That means what's happened? We consider a figure V1 dash to clear it, V2 dash, and here also V3 dash. If we take here another edges, that is V4 dash, so in this way we can find, and here it is V5 dash. If we consider another edges, E5 dash, here it is E4 dash, E3 dash, E1 dash, E2 dash. So in this way we find. If we consider here digraph, now here degree of the vertices, how to calculate? here it is dv dash. That means what is tail and what is head if we consider here. But now from here given figure v2 dash, in cases of v2 dash, the arrow headed is from v2 dash to v1 dash. So that's a starting vertex, that is called tail, and it's going to head. But here the number of the arcs, that means and that means starting vertex, and that means the starting vertex, and end is designed as head or the terminal vertex. Here end is designed. So here it will be the out degree we consider here. It's an out degree function. It's clear. So it will be d plus of v2 dash. That will be clear from tail to head. If we consider here v1 dash, okay, it's a v1 dash, v2 to v1 dash. So out degree only 1. So it will be only 1. Only 1 out degree. D plus, that is a out degree, and here it is also out degree from v1 dash to v2 dash. So d plus of v1 dash, that will also be 1, and here also here also d3 and d1. Okay, and the number, that's a plus and in degree and out degree. So it is also clear d1 v and d, and here also observe that d minus of v3 dash, very very important here. Here it is going to head, that's why the number of the arc is going to head towards v3, v4 to v3 dash, v4 dash to v3 dash. So it will be 1. It is in degree, not out degree. And here also d plus of v4 dash, that will be, here is and here is, both have plus, that means tail to head, that means it is 2. D plus of v dash 5, it is going to v dash, so it will be only 1 in degree, and d minus of v dash 5, sorry, here d minus of v dash 5 and d plus of v dash 5, that means e dash, that's why it will be also 1. So here we consider the only vertices we are getting both in degrees and out degrees. And the loop, concept of loop, if we form any kind of loop like this, if we consider here E6 dash, then this will contribute as 2 because it's one in degree and one out degree. Contribute one in degree and one out degree. So D of V3 plus, it is a only one in degree and one out degree, that is it will be 2 considered if we consider as a loop. And in cases of the isolated vertices, both in degree and out degrees are 0 in cases of isolated vertices. So in this way we are getting some of the ideas, and one more idea we needed, that is called pendant vertices. A vertices V of digraph G is called pendant vertex of degree 1 if a vertices, let's say vertex V dash of a digraph G is pendant vertex if its degree is 1, that is D plus V dash plus D minus V dash, that will be 1. So we end our discussions. If you like the videos, like it, share it, and subscribe the channel. Thanks for watching.